Effective energy consumption in wireless networks. The rise in number of mobile phone users and telecommunication systems have drastically increased power consumption. This project proposes green radio technology, which aims at an environmental friendly approach by conservation of energy and reduction of CO2 emission. Also, the self-power usage of towers can be met by employing renewable sources like solar and wind energy. The hybrid board. Using the hybrid board, we will be showing generation of solar and wind energy. The mechanical energy and light energy are converted as electrical voltage input after passing through a step-down transformer. The green radio board used will obtain parameters such as humidity, temperature, light, current and voltage through various sensors like thermistors and LDR. Current and voltage are given through a step-down transformer. The embedded board used comprises of MSP 430 IC. A relay switch is used as a switching on device. The frequency generator board used will generate a responder frequency. The frequency of the previous tower is generated using this board. A wireless transmitter board is used to transmit frequency to the next tower in order to switch it on if the number of users per single tower is exceeded. This is the simulation screen shown. The various parameters will be measured and displayed on the screen as shown. The pic on the left hand side shows the previous tower, the center one shows the current tower in use, and the right hand side shows the tower ready to be switched on. Now we will be seeing the simulation of the green radio technology. The responder frequency is now released. Using a low capacity load, a bulb, the switching on of a tower is depicted. Power is obtained as a product of voltage and current, and accordingly the user density is calculated. We can see the user limit below 1000 and therefore the previous tower does not switch on the next tower. A high capacity load is now used. The user limit is increased and a responder frequency is transmitted via wireless to switch on the next tower. We can see that the LDR is used to detect the amount of light, and thus a low light condition will result in the light to be switched on the transmission tower. Air conditioning in the current scenario is continuously working. This leads to wastage of power. Here, a temperature above 40 degrees Celsius will enable the AC to be switched on. If the humidity rises beyond 70%, there will be no need of external cooling. Now we will see the simulation of hybrid energy generated using solar and wind power. Light energy on the solar panel results in increase of voltage produced from the light energy. This can be seen on the analog value. Similarly, rotation of wind rotor results in increase of analog voltage on the simulation screen. Hence, power required for the functioning of transmission can be generated by self using wind and solar energy.